Welcome to Lab 5 of EC114. In this lab, we'll look at some advanced data management techniques using data, mainly how to reshape a data matrix and how to merge data sets. For this lab, I will use some data extracted from the World Bank, as you'll in many cases have to use data sets that are downloaded from the internet, and you'll need to understand the structure of these data matrices and many times how to combine them together to produce one unique data set. That is the case when you have to download multiple economic series for many countries, and you will have to then merge all the data for these series into one big data set in Stata. And we'll look at how to do that today with a very simple example with data extracted from the World Data Bank. So in the World Data Bank page, load two different series for all the countries. Series we'll download are going to be GDP and GDP growth. So we'll do that for all the countries in the database. And we'll download the series for the period between 2012 and 2000. So when we download this dataset, we'll save it as an Excel file and we download it. The outcome is going to be this. An Excel file where we have the countries in the rows along with the indicator variable. Here is GDP growth, and if we scroll down we will find GDP in current US dollars. And what we'll use data for is to reshape this data matrix such that we end up with years on the rows and each of these indicators on the columns. And I will teach you a very simple way of doing it that you can apply for other data management cases you will have along the way. So we'll just save this as a CSV file, which is already saved here, and then we'll bring this into Stata. So let's first set up our working directory, close any open log file, and start our new log file for today. And let's import the dataset with the insheet command. So this is what we get. We have three named variables and then variables from 4 to 16. If we look in the data editor, this looks a little bit messy, but essentially we have indicator name, country code, and these variables v4 to v16 are going to be the years, and the years are displayed on the label because data cannot take a variable name that is just a number. So the labels indicate the years for the corresponding variable. So first thing we'll need to do is to restrict the sample to only GDP in US dollars, and we'll save this series and we'll do the same procedure we're going to do now for GDP growth. We will save that, and then we will merge the two Stata datasets together, and we will have GDP and GDP growth in the same dataset for all these countries from 2000 until 2012. So first we need to rename each variable with the indicator that we're using, in this case GDP, and the year corresponding to each of the columns. You will understand why we're using GDP as the indicator and why we're renaming it in this way. So this is the first step. Now we can see all the variables changed name. And with this, we're able to reshape the data matrix. So essentially, we're going to use the reshape command, which has a very helpful help file, and where essentially you can use this command to reshape a data matrix from long to wide or from wide to long. And here it explains the ij variables you need to have. In this case, we're going to reshape from wide into long. So we have our I variable, which represents country. So we have country 1, country 2, and we have our j variable here, which is going to be year, as year 1, year 2, year 3, year 4. So you can think of stub here as our GDP variable. So we have GDP 2000, GDP 2001, etc. until GDP 2012. And we want to replace this as, or reshape this as long with this structure where we have country, year, and our GDP variable. And each country repeats for the number of years we have in our sample. The syntax is very simple, but there are some complications here and there, so this is not a command that is easy to get and implement, but once you practice, you'll be able to implement this easily. So syntax is simple. We want to reshape long GDP, and that is why I named GDP in these variables here, where I is country code, which I could have given country name as well, but country code, I know that it uniquely identifies each country in the sample, and j is going to be our year variable we're going to create. It doesn't exist yet, but Stata will extract this portion of the string. It will keep this as one variable, and it will revert this onto the rows of our data. We need to make sure that we have deleted the observations that are not part of GDP in US dollars, so the observations that are part of GDP growth. After we have deleted them from the dataset, we can now reshape our data. And this is the output we get. So j, the variable year, goes from 2000 to 2012. We had 246 observations. We have had 206 observations before, which corresponded to the number of countries. Now we have 3,198 because for each country we now have 12 observations corresponding to each of the years. We had 16 variables, now we only have 5. The j variable was created into year, and the xij variable GDP 2000 were now stored into GDP, so we can look at data browser to understand the changes we made to the matrix. So now, for example, Aruba, we have the first 13 observations, one for each of the years in our data set, and we have the corresponding GDP value for it. And we'll have the same for all the countries in our data set. And now what we wish to make happen is to bring the GDP growth variable onto this column here. And we will do that with the merged command. So we'll use this same procedure for the dataset that only contains observations related to GDP growth, and then we will merge that information using country code year, which will be the observations that, or the variables that uniquely identify each observation in our dataset. So we can see that country code does not uniquely identify observations in our dataset because, well, observations 1 to 13 have all the same string. But the combination country code year is unique to each observation. It doesn't repeat itself. If it repeats itself, we also design a procedure to tell us whether that happens and to tell us where is that happening, so we can have a new look at a data matrix and correct any mistakes that we may have produced along the way or that may have been built into the matrix when we downloaded the matrix from the World Data Bank website. But essentially, country code year is going to uniquely identify each observation, which will allow us to merge the information with the other variable GDP growth. So we will save this data set. First, let's sort country code year and save dataset gdp.dta with the option replace. In case there is a dataset already created with this name, we want to replace it. This data tells us that there is no file with such name found, but in any case it saves the dataset. We will do the same for GDP growth. So again, we will insheet the main CSV file that has both indicators. This time we will keep observations if the indicator name for that observation is equal GDP growth annual %. And you have to copy the string exactly as it appears in indicator name. So if you tab indicator name, you'll have to copy this precisely. We'll rename all the variables with growth followed by the year. Let's make sure we run this bit of the command. So we deleted 246 observations, and now we can reshape long growth, where I is country code and J, the new variable to be created, is year. So essentially we just have to copy paste the code we've written before and replace GDP with growth. Again, it worked. No errors pointing out to possible mistakes. Let's sort country code year now, and let's save the dataset as growth.dta. So we can see that now we have exactly the same variables for the GDP dataset, and we have this column here, growth, which we wish to merge with the GDP dataset. All the other variables are the same, and the two variables, a combination of country code year, they uniquely identify the observation, so we will use these two variables to merge the information with the merge command. But first we need to check for possible duplicate observations in our data matrices. If it is not the case that country code year uniquely identify each observation, if for some reason there's a duplicate, that could happen, for example, if we did not have a very good estimates, for example, for GDP growth or GDP for developing countries, or there was some external shock which made those statistics for that particular year to be dubious, and there are several estimates for these statistics. For example, if we imagine for ruble, we would have one estimate in the first observation, and then we would have again ABW 2000 and then a second estimate for GDP growth, because there is some uncertainty around the statistic in that year. If the data would have been given to us in that format, we would have a repeated observation, and Stata would not be able to merge this value of GDP growth with the same value, with the value for the same year and country in the GDP dataset, and essentially that is a source of conflict. So for that, we can simply write a loop which will go through the two data sets that we have. In case you have, I've written the loop in case you have a larger number of data sets that you want to merge together. That is the case if you have multiple series you want to merge together in one data set, and you can essentially write the loop so that it goes through all of these files and then brings them or essentially performs the same task and tells you whether you have a problem or not. So for that we'll use a global. This is part of the advanced stuff you can accomplish in Stata. A global essentially creates a file list which is called GDP and growth. You can add other possible series that you have. Once you call this file list, you are able then to tell Stata to go through each of the elements of this list and perform a particular task. That we will do with the for each loop. For each basically says for each element of something, and you open brackets, perform all these tasks and then close brackets and then end the task. So what we're saying here is for each file in the file list we created, and you have to refer to the file list with a $sign here. So for each file in the file list, so for each file is going to be for GDP and then for growth, use file.eta, and you refer to the file with this syntax so that Stata knows that it will replace this value here with each of the elements of the list. So it will replace this whole expression with GDP, and then it will use gdp.eta, and then it will replace this expression with growth, and it will use growth.eta, etc. for all the elements in your list. It will use the file and by sort country code year, which are the two variables that uniquely identify each of the observations in our data set. So for each combination of country code and the year, generate a duplicate variable, and the duplicate variable is essentially a condition, and the condition is if the total number of observations is equal to 1 for this combination. So if the total number of observations for the combination UK 2000 is 1, give 0 to my variable duplicate. If it's different from 1, then just give me the number of observations that you find. So Stata essentially will try to find the number of observations that have the combination UK 2000, and then it will either give it a 0 if the number of observations is 1, or it will give it the number of observations if it's larger than 1. And we essentially want to assert that duplicate is equal to 0. We want to make sure that we do not have any duplicates in our data set. So if we run all this together, there's no mistake, there's no error, there's nothing telling us that this did not work. If I happen to exclude year from our condition here, then we're essentially saying by country code, tell me if there are any duplicates in my data sets. Well, country code repeats itself for each year of the series that we're looking at. So by definition, we already know that are duplicates. So if I run this loop again, it will give me an error because for the very first file, it essentially encountered 3,198 contradictions to my assertion here that duplicate was equal to 0. And we can essentially tab duplicate and find that it's actually equal to 13. So it repeats, each country code repeats itself 13 times, which is equivalent to the number of years that we have in our sample. But country code is a unique identifier of observations, and that is exactly what we need to merge the files. To merge the file, essentially we need to first open one of the data sets, doesn't matter which, and we'll use the following syntax, the merge command, and the merge command can take different options. You can merge each observation one to one. You can merge multiple observations onto one observation, so the first number is always the dataset you are using, the master dataset actually, which is this one, the dataset that is open, and the second number is the dataset that you are bringing into Stata. So in this case, we have a one-to-one matching because each observation in each dataset is going to match in terms of the country and the year. If we had repeated country years in the dataset GDP, we would use many-to-one. If we had repeated observations for country year in the using dataset, we will use M in the second number. But here we have a merge one-to-one, and then we indicate the variables that uniquely identify observations in both datasets. This case is country code and year. And we finally do using, and we write the name of the dataset we're bringing to merge with the current dataset. Stata gives us a result for the matching. There were 0 observations non-matched, and there were 3,198 observations matched. You can essentially get the same results by doing tab variable merge, which is created with this merge information, and all the observations were matched. So we can drop this variable. Essentially we have to drop it before we produce a second merge, because Stata will try to create the same variable and it has already been created. So we drop this variable, and we can now look at the data matrix and confirm we have the variables for GDP and GDP growth for all the country year pairs. And this is how we are able to merge information that we download from a particular data source. We reshape the data matrix to make sure that we're able to get information as we want, in this case with country and years in the rows and each of the variables in the columns. And we can scatter this information and perform any other kind of analysis. So all we have left to do is to save the new dataset with a meaningful name and keep on adding other series if that is the case, or just perform our analysis with this one. And finally, close our log file.